Laws of exponent. Welcome back. Exponents. I will be discussing, as I promised, this one. A raised to x multiplied by a raised to y is equal to a raised to x plus y. Others are using m and n. It doesn't matter. I'm using x and y. That means if I have 2 raised to 3 multiplied by 2 raised to 4, then I have 2 raised to 3 plus 4, which equal to 2 raised to 7. How did it go? It will look like this. 2 times 2 times 2, that is the 2 raised to 3, multiplied by 2 times 2 times 2, 2. Then we have 2 times 7. That's the reason why. As you can only use this when you have the same base. You cannot use this when you have, for example, 2 raised to 3 multiplied by 3 raised to 2, for example. If you have this kind of problem, then you need to calculate the 2 raised to 3 and then calculate 3 raised to 2 and then multiply it 9 times or 8 times 9, 72, for example. So you cannot use this law of exponent when we have we don't have the same base. The next law of exponent that I'm going to discuss is this one. When you divide two exponents with the same base, then you can use this law. You can subtract their exponents. So for example, we have 2 raised to 4 divided by 2 raised to 3. And we have 2 raised to 4 minus 3 is equal to 2 raised to 1, or just 2. Why? Because of this. 2 times 2 times 2 times 2 divided by 2 times 2 is 2. When the numerator and denominator are the same, then it will become 1. So you can cancel the 3 2's. So, and the only remaining is 2 raised to 1, or just 2. That's one of the reason, or that's the proof, numerical proof of this law of exponent. It is called division. The first one is law of exponent in multiplication. Okay, and then the next that I'm going to discuss is a raised to x, this one now, a raised to x raised to y. Then all you need to do is to find the product of the exponent. That means if I have 2 raised to 4 raised to 3, then I have 2 raised to 4 times 3, which is 2 raised to 12. Why? Because if I have this one now, 2 raised to 4 multiplied by 2 raised to 4 multiplied by 2 raised to 4, you can see that I have, from the first law, I can add their exponent. Where am I? A raised, oh sorry, not A, It's 2. 2 raised to 4 plus 4 plus 4 is equal to 2 raised to 12. But you don't need to do this one. You can just use this law. Then you're off with it. You're good with it. The next one is this one. Why I don't have again this is my next. So that is a raised to x, b raised to x is equal to ab raised to x. That means if I will do the other way around. If I have 2 times 3 raised to 4, for example, then I can do this one. 2 times 3, 2 times 3, 2 times 3, and then another one, 2 times 3. Then as you can see, we have 2 raised to 4. We have 1, 2, 3, 4. And then we have 3 raised to 4. So this also, instead of doing this very long solution, then you can just use this equation or this law of exponent. That if you have 2 raised to 4 multiplied by 3 raised to 4, then it is the same as to say that 2 times 3 raised to 4. This is just a review. And then the last one, no, not the last one. The next one is this one. So that, wait, what happened? Where am I? Here. There I am. A raised to x divided by b raised to x is equal to a divided by b, in the parenthesis, raised to x. I will do the other way around again. For example, I have 2 divided by 3 raised to 4. That means I have 2 thirds multiplied by 2 thirds multiplied by 2 thirds and then multiplied by 2 thirds. Then as you can see, I have 2 raised to 4. I can multiply all just the numerator first, and then I can also multiply the denominator, 3 raised to 4. As you can see, you can use this. These are the tools. You can use them when you need them, but you need to know when to use them. It's very important. And now, the next that I'm going to discuss is this one. I have a lot of students who have a problem with this. It's very easy. It's very easy to prove. It's very easy to understand, but I have a lot of students who doesn't understand it. So let's see. We have this. A raised to 0 is equal to 1. For example, I can prove that by using this rule. I can do this one. A raised to x divided by a raised to y is equal to a raised to x minus 1 y. As you have learned in rational expressions or in fractions, when the numerator and the denominator are equal, then you have the answer of 1. For example, 2 divided by 2, that is 1. So for example, I have a raised to x divided by a raised to x, that is 1. But if we're going to use this law of exponent. So I have a raised to x divided by a raised to x is equal to a raised to x minus x. That is equal to a raised to 0. That means a raised to x divided by a raised to x is equal to a raised to 0, which is also equal to 1. That's why we have a raised to 0 is equal to 1. I will give some more example. For example, 5 raised to 3 divided by 5 raised to 3. As we know, that is 1. But we can use the law on division, law of exponent and division. So we have 3 minus 3, that is also 5 raised to 0. So any number raised to 0 is equal to 1. If you don't understand the proof or the explanation at this moment, you will understand it later, but at this moment, you can just accept it. I usually say that to my students, that they can accept it now and then understand it later. But there are a lot of students who doesn't understand this equation, this law. And then the last that I'm going to discuss is this one, the negative exponent. A raised to x. Negative x is equal to a divided by a raised to x. This one, the last one there. As with the 0 exponent, I have a lot of students finding a hard time understanding this law of exponent. Okay, let's see. How could we show that? For example, 5 raised to 3 divided by 5 raised to 7, for example. And then we have, according to this law on division on exponents, then we have 5 raised to 3 minus 7. Then we have 5 raised to negative 4. That's it. Then we have, but as you can see, I can write also my expression into factor form. 5 raised to 3 is the same as 5 times 3 times 3. 5 times 5 times 5, sorry. And my divisor is 5 times 5 times 5, 7 times. We will do this. Maybe it's boring, but you will understand later. 1, 1, 1. And then the numerator now is 1, and the denominator is 5 raised to 4. That means 5 raised to negative 4 is equal to 1 divided by 5 raised to positive 4. Remember now, when we have negative as a numerator, then we kick that expression, and then we have 1 as numerator, and then the denominator will be the same expression with a positive exponent. Okay, well, let's try one more time. We have 3 raised to 3, and then 3 raised to 9. Then we have 3 raised to 3 minus 9 is equal to 3 raised to negative 6. Doing the factor, 3 raised to 3 times 1, we will say. No, I'm not going to put 1 there. It will confuse you. And then we have 3 raised to 3 times 3 raised to 3 times 3 raised to 3. As you can see now, this one will be 1. Then I have already 1 divided by 3 raised to 6 according to this law, the law of exponent in multiplication. So as you can see, 3 raised to negative 6 is equal to 1 divided by 3 raised to positive 6. The same is true when you have there is a subsequent rule on this also. If I have 1 divided by 3 raised to negative 6, then that will be equal to 3 raised to 6. Why? Because 3 raised to 6, 3 raised to this one is the same as 3 raised to 0, as we have decided, as we have proved in the previous one. And then 3 raised to negative 6, then we have 3 raised to 0 minus negative 6. As you can see now, it is 3 raised to positive 6. So it is very important that you will understand this. I hope you understood a little bit. This is just a repetition on laws of exponent. But for those who have read basic algebra, but for those who didn't, then this is a very simple explanation of the laws of exponent. So I hope it helped you a little bit. Then next time, then I will be discussing more examples on the zero exponents and positive exponents, negative exponents. See you there.